All right, this is PreCalc 8.3, the review worksheet. On this review sheet, for the first 5 questions, you're not supposed to use a calculator. These are all going to give you angles that go back to our 30, 60, 90 triangle and our 45, 45, 90 triangle. Also, in the directions right there, it says find all solutions. And your hint is that's where you're adding and subtracting the 2k pi. So for number 1, we want to isolate our cosine. So we're going to subtract 4. And then we're going to divide by that 8. So we're going to get cosine x equals negative 1/2 when you reduce that. So then you want to take the inverse cosine of that negative 1/2. And that's looking at our triangle. We know that we have our triangle here. That gives us this bigger angle. This is adjacent over hypotenuse. So this is a 60-degree reference angle, but we're looking for that bigger angle, which gives us 2 pi over 3. But then we need to figure out where else cosine is negative, and that's in the 3rd quadrant. So we have to find our pi over 3 angle that's in the 3rd quadrant, and that is 5 pi over 3. So it's very important to know your unit circle for these. So these are our 2 angles where cosine is negative, where you get that negative 1/2, and it wants all solutions. So plus or minus 2k pi on each one. So these 2 are your solutions here. 2 pi over 3 plus or minus 2k pi, 5 pi over 3 plus or minus 2k pi. Number 2. Again, you want to isolate your sine x. So we're going to divide by that root 2. So we get 1 over root 2. So again, we're going to use our triangle. We have opposite over hypotenuse. So that gives us a 45-degree angle, or a pi over 4. That's also, by the way, that's when you take the inverse sine of 1 over root 2. You get that pi over 4. So then you have to think, where else is sine positive? That's in the 2nd quadrant. And the pi over 4 angle in your 2nd quadrant is 3 pi over 4. And again, we want all solutions, so plus or minus 2k pi on each of these. Number 3. This time we have that weird something's happening with our x. So again, you're going to do like you normally would, isolate your cosine. So we're going to end up with cosine x over 4 equals 1/2. We're going to solve this like we normally would. We're going to ignore this x over 4 for right now. We're going to solve this just like it was cosine x. So that goes back to our triangle. You have adjacent over hypotenuse. So that's a 2. That gives us a pi over 3 angle. So inverse cosine of that 1/2. Gives us a pi over 3 angle. And then where else is cosine positive? That's in the 4th quadrant. Our pi over 3 in the 4th quadrant is 5 pi over 3. And again, we want all solutions, so we plus or minus that 2k pi. Now, these are not our solutions. This is if we had solved as if this were just an x. So we're going to set each of these equal to that x over 4. So we set x over 4 equals pi over 3 plus or minus 2k pi. And x over 4 equals 5 pi over 3 plus or minus 2k pi. And then we're going to solve for x. So we're going to essentially multiply each of these by 4. And when you multiply by 4, remember that you are multiplying the entire thing by 4. So you're going to end up with x equals 4 pi over 3 plus or minus. Multiply this 2k pi by 4. So you end up with 8k pi. And then the second one, x equals 20 pi over 3 plus or minus 8k pi. So you need to multiply the entire thing by that 4. So you get 4 pi over 3 plus or minus 8k pi, and 20 pi over 3 plus or minus 8k pi for number 3. For number 4, again we want to isolate that sine 2x, and we'll deal with the 2x later. So we're going to get sine 2x equals negative root 3 over 2. That goes back to our triangle. We have opposite over hypotenuse. So we're looking for that angle when we take the inverse sine of negative root 3 over 2. That's going to give us a negative pi over 3. But remember, which you can use, we could use our negative pi over 3 because this is just asking for all angles, so you can use that. Another name for that negative pi over 3 is your pi over 3 angle in the fourth quadrant, which is that 5 pi over 3 again. So either one of those gives you that angle. And then sine is also negative in the third quadrant, and that angle is 4 pi over 3. So then we have to set those equal to that 2x. So we'll use the negative pi over 3, and then that's plus or minus 2k pi. And then we have 2x equals that 4 pi over 3 plus or minus 2k pi. Miss Audie's room. No, I think she's down in the office. Oh, okay. Yeah, I think she's in the office. Bye. Okay, so continuing on with this one. So now we have to solve for x. So we're going to divide by 2 to solve for x. So, for our first part, when we divide by 2, remember you're dividing the entire thing by 2. You're going to end up with negative pi over 6 plus or minus k pi, because we divided that by 2 as well. And then for the second one, we get 4 pi over 6, which equals 2 pi over 3 plus or minus k pi. Again, dividing that 2k pi by 2. Now if you had used the 5 pi over 3 instead of the negative pi over 3, you would have 5 pi over 6 plus or minus k pi. So you would either have this and this, or you would have this and the 2 pi over 3. So either these two or these two. For number 5, we have tangent 3x equals -1. So this one, we don't have to isolate our tangent, it's already isolated for us. So we're going to solve this just like we were solving inverse tangent of -1. So that takes us into the 4th quadrant. We have opposite over adjacent. That gives us a negative pi over 4 angle, or a 7 pi over, or a 3 pi over 4 angle, sorry. Or no, yeah. The 4th quadrant is 7 pi over 4. And then we need to think where else sine is, or tangent is negative. Tangent is also negative in the 2nd quadrant. That gives us a 3 pi over 4 angle. And again, we want all solutions, so that would be plus or minus the 2k pi. But we need to set it equal. We need to set these angles that we just found equal to that 3x. So we're going to have 3x equals that negative pi over 4 plus or minus 2k pi, which is going to give us x equals negative pi over 12 plus or minus 2 divided by 3k pi, so 2/3 k pi. Or if we use that 7 pi over 12, we would have 3x equals 7 pi over 4 plus or minus 2k pi, which would give us x equals 7 pi over 12 plus or minus 2/3 k pi. So either one of these answers is good for that 4th quadrant angle. Then we also have our 3 pi over 4. So 3x equals that 3 pi over 4 plus or minus 2k pi. And again, you're going to divide by 3. So you're going to get x equals 3 pi divided by 12 plus or minus 2 over 3k pi. And this reduces to pi over 4 plus or minus 2/3 k pi. So you should have 2 answers for this. You can either have, you will have this one, the pi over 4 plus or minus 2/3 k pi. And then you can have either the negative pi over 12 or the 7 pi over 12. Either one of those is equivalent. Those are both 4th quadrant angles. So you would have one or the other. Now for number 6 through 8, we're punching these into the calculator. So for number 6, we want to find the inverse cosine of, remember when you're given this negative, you want to find the positive one first and then use that as your reference angle. So we're going to take the inverse cosine of 0.345, which is going to give us 1.2186. Now we're going to use that angle to find where cosine is negative. So cosine is negative in quadrants 2 and 3. So to find our 2nd quadrant, we're going to take pi minus the value that we found here. And we end up with 4.3602. And then we want to find the 3rd quadrant, which is pi plus that value, so that 1.2186. And we end up with 5.0646. Now in our directions it says to solve using the calculator and find all answers from 0 to 2 pi. So from 0 to 2 pi we have our 2nd quadrant and our 3rd quadrant, so those are our 2 answers. Number 7. we want to isolate our sign first, so we're going to divide by 2. So we have sine x equals 0.0615 when you divide by 2. So we're going to take the inverse sine of that 0.0615, and that gives us 0.0615 back. And we're in quadrants 1 and 2 is where sine is positive. So we already found quadrant 1 is that 0.0615. So to find quadrant 2, we're going to take pi minus that 0.0615, and we're going to get 3.0801. And again, we're just going 0 to 2 pi, so you just have those two answers. Number 8, we're taking tangent x of negative 1.3. So again, we want to take the inverse tangent of the positive 1.3. That's going to give us 0.9151. Tangent is negative in the second and fourth quadrant. So we're looking at quadrants 2 and 4. So to find 2, we take pi minus that value, so 0.9151. And that's going to give us 2.2265. And then the fourth quadrant is 2 pi minus our value, which is 0.9151 again. And we get 5.3681. For 9 through 11, we again want to find all solutions. So again, we want to isolate our sign. So we have sine 2x equals 3/4 when we divide by 4. So again, we're going to take the inverse sine of that 3/4. That's going to give us 0.8481. And we're looking for where sine is positive, so that's quadrants 1 and 2. So we need to find our sine in the second quadrant, so pi minus this 0.8481, which gives us 2.2935. So now these two values that we just found, we need to set equal to that 2x. And remember, we want all solutions, so we add and subtract 2k pi to both of those values. So we have 2x equals 0.8481 plus or minus 2k pi. So we end up with x equals 0.4241 plus or minus k pi. Remember to divide that 2k pi by that 2 as well. And then our second value, we have 2x equals that 2.2935 plus or minus 2k pi. Dividing by 2, you get that x equals 1.1468 plus or minus k pi. So your two answers are 1.1468 plus or minus 2k pi and 0.4241 plus or minus k pi. Number 10. Again, we want to isolate our cosine. So we're going to have cosine of x over 2 equals negative 0.12.
Yeah.
When you take the inverse cosine, remember that you want to take
Okay.
the inverse cosine of the positive. So we're taking the inverse cosine of 0.21, which is going to give us 1.4505. We're going to use that to find where cosine is negative. And cosine is negative in quadrants 2 and 3. So to find our angle in quadrant 2, we take pi minus 1.4505, and we get 1.6911, and we want all solutions, so again, plus or minus 2k pi. And then in the third quadrant, we have pi plus 1.4505, which gives us 4.5921 plus or minus 2k pi. So then we have to set those equal to that x over 2. So we set each of our answers equal to x over 2. So x over 2 equals 1.6911 plus or minus 2k pi. We get x equals, multiplying by 2, we get x equals 3.3822 plus or minus 4k pi now. And then setting x over 2 equal to 1.4505. Oops. Setting it equal to 4.5921. That was our other value here. Plus or minus 2k pi gives us x equals 9.1842 plus or minus 4k pi. So you get that answer, and you get that answer. And finally for number 11, we're taking the tangent 3x equals negative 2.75. So again, for this one, we're going to take our inverse tangent of the positive, so of positive 2.75, which is going to give us 1.2220. And we have to think, where is tangent negative? So we're looking at quadrants 2 and 4. So quadrant 2 is pi minus 1.2220, which gives us 1.9196. And then the fourth quadrant is 2 pi minus that 1.2220, which gives us 5.0612. And again, we want all solutions, so plus or minus 2k pi. And then we have to set those values equal to 3x. So we have 3x equals 1.9196 plus or minus 2k pi. Solving for x, we divide by 3. So we get 0.6399 plus or minus 2/3 k pi. And then for our fourth quadrant, we have 3x equals 5.0612 plus or minus the 2k pi. Dividing by 3, we get x equals 1.6871 plus or minus 2/3 k pi. So you end up with this answer and this answer. on to the back page. The back page is all factoring. We're using the quadratic equation. When possible, always factor. It will save you time. So for number 12, and we're also looking for in the interval 0 to 2 pi. So we're not adding and subtracting that 2k pi this time. So for number 12, we're going to move this 2 over. We're going to have 2 sine squared x minus 3 sine x minus 2 equals 0. And then we're going to factor. I'm going to leave the signs in, but you don't have to when you're factoring these. So I have 2 sine x and sine x. And this is going to be a plus 1. This is going to be a minus 2. You're going to set each one of these equal to 0. So you're going to have 2 sine x plus 1 equals 0. And sine x minus 2 equals 0. Isolating your sign, you're going to get sine x equals -1/2 for this first one. For the second one, you're going to get sine x equals 2. So to solve this first one, that -1/2 tells us that it's in our triangle. So if we draw a triangle off to the side here, we have opposite over hypotenuse. That tells us that this is a negative pi over 6 angle, but we want to be between 0 and 2 pi. So we want to find the pi over 6 angle that's in the 4th quadrant, which is 11 pi over 6. And then we need to find where else sine is negative. Sine is also negative in the 3rd quadrant. So we're looking for the pi over 6 angle that's in the 3rd quadrant, which is 7 pi over 6. So those are your 2 angles where sine equals -1/2. Now, on this other side, we have sine x equals 2. So this goes back to thinking about our domain for sine, cosine, and tangent. So for sine and cosine, our domain was -1 to 1. This 2 is outside of that -1 to 1. So this one is not going to have a solution. So we're only going to have these 2 angles, the 11 pi over 6 and the 7 pi over 6. And again, we're only finding between 0 and 2 pi, so we don't have to add and subtract that 2k pi. Number 13. Number 13, we're going to factor. We have sine x and sine x. And we're going to add 2 and subtract 1. So that's how that factors. Set each of those equal to 0. Solve for sine. For this one, you get sine x equals -2. For this one, we get sine x equals 1. So for this first one, again, this is outside of our domain, so no solution. This one goes back to our triangle. This one doesn't actually use the triangle, it's going to use the unit circle definition of y over r. So we're looking for where y is 1, and that's up here at pi over 2, because that point is 0, 1. And that's the only point where sine equals 1. So when we take the inverse sine of 1, we're going to get pi over 2. And that's the only angle where it equals 1. So our only answer for 13 is pi over 2. Number 14, we have cosine squared minus 1. This one is a difference of perfect squares. So you have cosine x plus 1 times cosine x minus 1. Set each one of those equal to 0. You're going to have cosine x plus 1 equals 0. Cosine x minus 1 equals 0. You'll have cosine x equals negative 1. Cosine x equals 1. Take the inverse cosine of negative 1, the inverse cosine of positive 1. This goes back to our triangle, well, our unit circle. Our definition for cosine was x over r. So for inverse cosine of negative 1, we're looking for where x is negative 1. That's back here at pi. So you're going to get pi for the inverse cosine of negative 1. And then inverse cosine of 1, you're looking for where x is 1. And that's here at 0. Remember, we're looking at 0 to 2 pi. So the answer for that one is 0. So our two angles are pi and 0 for this one. Those are the only spots for each one where they equal negative 1 and 1. So you get pi and 0. Number 15. Again, we're going to factor this. When we factor this, we get cosine x minus 2, cosine x minus 1. Set each of those equal to 0. So you get cosine x equals 2 and cosine x equals 1. Again, domain. Cosine, the domain was negative 1 to 1. This is outside of our domain, so we have no solution for that part. But then we have the cosine of 1. We're going to take the inverse cosine of 1, which is again going to give us 0, just like we got in 14. So our only answer for 15 is 0. Number 16. We're going to move this 3 over, so we're going to have 2 sine squared x plus 5 sine x minus 3 equals 0. We're then going to factor that. So we're going to get 2 sine x and sine x. And we're going to have minus 1 plus 3. Set each one equal to 0, so we have 2 sine x minus 1 equals 0. Sine x plus 3 equals 0. Solving for sine, you get sine x equals 1/2. Sine x equals negative 3. Sine of 1/2 goes back to our triangle. We have opposite over hypotenuse. So the inverse sine of 1/2 gives us a pi over 6 angle. And then we have to think where else sine is positive, and that's in the second quadrant. So we need our pi over 6 angle in the second quadrant, which is 5 pi over 6. So those are your two answers for the inverse sine of 1/2. And then looking at sine x of negative 3, if we take the inverse sine, this is outside of our domain. So again, we have no solution for that part. So we're only going to have these two angles. Number 17. 17, we're going to factor out that sine x. So we have sine x times cosine x minus 1, and that equals 0. Set each part equal to 0, so we have sine x equals 0, cosine x minus 1 equals 0. Sine x equals to 0 goes back to our y over r definition, so we're looking for where y equals 0. Y equals 0 at 0 and pi, so at both places on our x-axis. So we get, for the inverse sine of 0, we get 0 and pi. And then for cosine x minus 1, we get cosine x equals 1. So we take the inverse cosine of 1, which again equals 0. So our answers for this one are going to be just 0 and pi. Don't repeat the 0 twice. And then finally, number 18. If you haven't guessed already, number 18 is the one that we're going to have to use the quadratic equation on because it does not factor. So just a reminder, the quadratic equation is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So we're going to find that sine x equals negative 2 plus or minus the square root of 4, because we have 2 squared minus 4 times negative 2, so it's actually going to be plus 8. And that's going to be divided by 2 times 1, which is our a value, so just 2. Now, separating our two values, we're going to get sine x equals negative 2 plus root 12 over 2, and sine x equals negative 2 minus root 12 over 2. Solving each of these as a decimal, we're going to get sine x equals 0.7321, and sine x equals negative 2.7320. So looking at our two answers, if we were to take the inverse sine of our second one, this again is going to be outside of our domain, so we get no solution. But then looking at our second one, we're going to take the inverse sine of that 0.7321, and we're going to get 0.8214. So that's our first quadrant one, and we have to think where else is sine positive. Sine's also positive in the second quadrant. So we're going to take pi minus this value at 0.8214, and that gives us 2.3201. So again, because we're between 0 and 2 pi, these are our two answers, and you don't have to add or subtract that 2k pi. So these two values are your answer for 18. And that completes 8.3.